Oh, you are?
Okay. First question I have for you is what type of graph is this on number 13? Cube root, cube root. Okay, so got my thingies here. That's the technical name for them, the thingies. Here, okay. So my cube root is y equals a cube root x minus h plus k. Beautiful. Okay. And it says the inflection point is hk, which is this guy here. So that is -1, -2. And then it gave us 7, -3. Yep. Okay, great. Okay, so I have -3 equals a cube root 7 plus 1 minus 2. Okay, I like to rescue the 2. -1 equals a times the cube root of 8. What's the cube root of 8, everybody? -1 equals 2a. -1/2 equals. Yep. Okay. And then don't forget your final answer. Y equals -1/2 cube root x plus 1 minus 2. I feel like we've gotten pretty good at that. You like the solve for A? Did you like it with the sleeping parabola last night, though? That's a little bit. I like them. Nobody asked me. Oh, okay. All right, so there's number 13. Then scroll down when you're ready to number 15. And number 15 and 16 are weird ones. They've got kind of a different situation, so I want to make sure we talk about those slowly. Everybody good with 13? Okay. All right, so I'm gonna do the top one in pink and the bottom one in blue. You can do them in the same color. It doesn't matter. I'm just a nerd. And pencil. Okay. So the first equation is, I'm just gonna pretend I have equals just like everything else. So y equals x plus 3. And this is a really good reminder, math 1, how do I graph a line? So y-intercept is 3. Yep. Slope is 1. So up 1 over 1. Okay. And then I ask myself, dash or solid? Solid, and they're both solid. Right. So I'm going to test here. 0 is greater than or equal to 0 plus 3. 0 is greater than or equal to 3. Indeed, that is false. So I shade away from 0, 0. Okay, now I have y equals x minus 3. So down 3 for the y-intercept. This is parallel. Just throwing that little math one word in there for you. Also solid. Okay, now this is weird because you've got, yeah, you got a shade over top of that other shading. So that's your double shaded region. Kind of pretty, actually. So, do you remember on the test how it was multiple choice for this?
Yes.
And you remember how it only showed the double shaded as the shaded region for the on the test?
Sure.
It didn't have like two light and a dark. So in this problem, you would only see the two lines and the shaded part, the top shaded part, the double double part. Just so you know, that's how it would look in the final answer. Okay. I think no, we're not done with the packet. Can you look at last night's homework, please? The mid chapter. Okay, take a look through it. Tell me any problems that you have questions on. Anything? 10? Okay. Okay. So did we just did yesterday's warm up was this? So I got my blue pages up there, Sam. Okay. Start with the asymptote. Horizontal asymptote at y equals k. Mm-hmm. Okay, now I like to review this though because the locator point's so weird. The locator is h comma k plus a. Okay, what is h in this problem? -1. Okay. -2 plus 2, 0. Alrighty. 0 plus 1 is 1. 3 to the 1 is 3. 3 times 2 is 6. Minus 2 is 4. 1 plus 1 is 2. 3 to the 2 is 9. 9 times 2 is 18. Minus 2 is 16. This is going to be bad because it's going to be thirds and I hate thirds. So negative 2 plus 1 is negative 1. 3 to the negative 1 is 1/3. 1/3 times 2 is 2/3. Yeah. I'm going to put negative 1 and 1/3 just for graphing purposes. Me no likey. So this is 1/9, 2/9. 2/9 minus 18/9 is negative 16/9, which is negative 1 and 7/9. Yuck. Cripes. You graphed it all wrong. Does that look like that picture on the answer page?
Yeah.
Anything else from the mid chapter, Violet? I can start 9. So, is that what the one you want to do? No, what do you want? Okay. So, number 9 is spicy. You have to add the 1 first before you start the problem. I don't want to do that yet. I'm ahead of myself. Okay, so Violet, you know how you're going to square both sides? You can't do it until the square root is alone. So on these problems, square root has to be alone first. Then you can square both sides. But then don't forget this side has to be a box. Do you think you have it from there? What? Oh, okay. So I'm gonna do a box for this. Okay, then you're gonna move this strip to this side and make it equal to 0. And then diamond and box. And then plug back into check. This one. You can't square that like that. Yeah, you might have gotten lucky. It might have been a cool video. Okay. Now up to number 8. Okay, that was Will. Okay, so 81 is 9 times 9, which is 3 times 3 times 3 times 3. So that's 3 to the 4th. Is that okay so far? Okay, so I'm going to make this 3 to the 4th, but then you multiply the little r on that's already up there. So that becomes 3 to the 4th r. Okay, and then I'm going to make this 3 to the 1 and bring him upstairs and make that 3 to the negative 1. So remember, when you switch sides of the fraction bar, it changes the sign. And then you have 4r equals negative 1, r equals negative 1/4. So there's 2 important things in this problem. First is the exponents multiply right here. So this becomes 4r. And the other thing is moving that upstairs makes that negative. Small amount of work, but kind of spicy. Yes, honey. What was 5? I forgot. Oh, I'll start this one for you, Manny. Okay, so Manny, do you know what shape this is? Yep. Okay, so I got my sleeping parabola deal here. Are you with me so far? Okay, and this is the vertex, which is 2, 6, and that's HK. Okay, Manny, good. Okay, and then I need to find another point. The only other one I see is this guy right here. Yeah, which is probably my height now that I'm shrinking. And then plug in and solve for A. Do you think you can finish it from there? Okay, perfect. Alrighty, everybody. So I'm gonna stamp that soon, just for your information. But today we are working on problems 75 and 76, which are actually not in your notebook and they're not in your packet. It's the last entry in your blue sheet. Really bad news. There are more copies of it up there. Yeah, but they're plain, so just look for blue in the yeah. Okay, you guys, so we're gonna do all of the classwork on here. I'm also going to teach you how to graph logs on the graphing calculator and on Desmos today, but it's all going to be in terms of this paper. I want to go real slow, um, because logs have some weirdness. Of course they do. Okay, now if you remember from our previous work on the blue sheets, I used black pen, red pen, and a straight edge. So just to throw that out there if you want to keep your blue sheets consistent. Okay, the first thing is easy. Family name is logarithm. Mm-hmm. That's good stuff. Okay, now we're gonna pause here and talk about what possibilities there are for B. So if you remember, I really want to make sure if I teach you nothing in this last week, it's that the base of the exponent is the base of the log. So when we were writing logs from exponential form, there was 2 to the x, and the 2 was the base, and that became our little baby number in the log, which is our base. Okay, so B stands for base, specifically in these problems. And I want to talk about what the base can be because it's kind of weird. So to do that, I have brought up my best friend, Desmos. Okay, this is the graph of y equals log base 2 of x. And it's the inverse of the exponential 2 to the x. Does that make sense? We've talked about that, right?
Yes.
The 2 to the x would be the inverse of this. I want you to notice how Desmos does it correctly. The asymptote actually goes all the way down on the curve. And your graphing calculator is going to be dumb and it's not going to do that. You're going to have to draw it all the way down. It's not a big deal, but just giving you full warning. Okay. Now, I want you to see the shape of it. We've talked about the shape. And I want you to see what happens when I take this and I'm going to zoom in. I'm going to take the little baby base of 2 and I'm going to change it to a 1. No graph. Not possible. We will not do logs with a base of 1. Doesn't actually make anything. Okay, if you think about the Guinan circle, 1 to the something is 1. Always 1. Okay, also, if I change it to a 0, nothing. That would be 0 to the stuff. What's 0 to the 5? 0. What's 0 to the million? 0. 0 to that, 0. They're all 0, doesn't matter. Not interesting, not going to make a log picture. Okay, here's another fun, interesting fact. No negative bases either. You're not going to have negative bases. You're not going to have 0, and you're not going to have 1, which is great news. I know. That means that you get to use simple numbers for your logs. Okay, so we're going to put over here, B will not be 0. B will not be 1. And B is positive. And that's going to be forever. I mean, I've done a lot of math in my life. I've never done a log with base of 0, a log with base of 1, or a negative base, ever. I'll probably do more math than you guys will ever do. So, okay. Do you have any other interesting questions, though? Could it be a decimal? Yep, decimal's okay. It's coming from the other direction. That's all right. Not a big deal.
Oh, that's not bad.
We'll never do it, but I'm just telling you, those are all possible. Totally fine. The only things that are not fine are 0, 1, and negatives. Okay, so there goes that conversation. We're going to put that back to it. Oh, no. We're going to put that back to a 2. Okay. All right, so general equation, just like you might think. So the A goes in front. Log base B, which for us in this problem is going to be 2. We're going to choose it to be 2. X minus H plus K. Is that really that much different from what you would expect? No. Okay, A in the front, H in the parentheses, K outside. Not that big of a deal. Okay, locator point is very similar to the exponential. You cannot use HK. It's on the asymptote again. The locator point is H plus 1 comma K. Now you might wonder, especially I have some advanced math students in here, you might wonder why it's not H plus A comma K. Because exponentials is H comma K plus A. So you think you should just be able to flip flop it because they're inverses, right? Well, you can't. And I asked Mr. Knight to explain it to me last year about 5 times at lunch. And then I got so frustrated that I just gave up. So there it is. literally, I asked him to explain it to me, and it was like, it has to do with like the bases that we were talking about, the things that it can't be and whatever. And I was just like, you know what? There's no good way for me to explain this to children. They don't care nearly as much as I do. So h plus 1 comma k it is. All right. Asymptotes. Vertical at, what do you think? H. The whole plus 1 is to get it off of the asymptote. Okay. Now, end behavior, there's two options depending on if you have a positive A or a negative A. And we're going to stop that conversation right there and do our sketch. Okay. So over here, we're going to do some work. We're going to put in a base of 2. We need a base to be able to graph it. We're going to say 2 because we chose 2 as our base on our exponentials. Okay, so I want you guys to tell me, what is the vertical asymptote for log base 2 of x? Yeah, what else is in the parentheses? Nothing. Okay, so do your best to make a dashed line on the y-axis. Okay, and we're going to do the locator point, which is h plus 1 comma k. Okay, h is 0. So 0 plus 1. What's k? 0. So just decide a point that's going to be 1, 0. Okay, and then sketch this bad boy in. Come up along the asymptote. Go through 1, 0, and then curve off. Okay, now we're going to talk about end behavior because looking at the graph makes it a lot easier. This is saying as x goes forever to the left, my arrow is not going to go forever to the left. It stops at the asymptote. So there's no left end behavior. But as I go forever to the right, my arrow is going up. Okay, now we're going to sketch our friend. So can you guys flip your page over to the other side and find what A, H, and K were from all of our other transformed graphs that we did? Great job. Okay, and what did I do every time we graphed a transformed graph? I said, now find me the point 3, 4. Did I not say that every single time? Okay, so find me that point 3, 4. And it's not going to be on that point. So just hold that thought. here is the transformed equation that we're going to graph. Okay, and what is the vertical asymptote for this one?
Mm,
3. Okay, so you're gonna go through that point 3, 4. And now you can see why HK can't be the locator point. Okay. 3 plus 1 comma 4. Does this make sense? H plus 1 comma K? Yes?
Yeah.
So your locator point's actually 1 over from where you would think it is. Because it can't be on the asymptote. Can't touch the asymptote. It's hot. Lava. Can't touch it.
Nope.
Okay, now I'm going to show you what this guy looks like on Desmos so you can sketch him in. So he goes along the asymptote this way and then comes down in the opposite direction. Okay, so what do you notice about the end behavior? So the left arrow, is it going to go forever left? Nope. But the right arrow is going down. Okay, now I wanted to wait to do domain and range before we, after we had both graphs up there. Can you tell that both of the arrows are pointing to the right?
Mm.
Okay, so that means your domain is X is greater than H for all of them. They're not like the -2 isn't making it go in a different direction. It's just making it go down instead of up. Okay, and then the range, I just wrote the answer. Oh, yeah. I wrote the wrong R. Range is all real numbers for all of them. Okay, so now it's graphing calculator time. And this is going to take us a minute because everyone has different operating systems on their calculators. Yes, honey. You sure? Right now? I guess. I mean, let me just figure out what I think your calculator's like mine, right? Yeah. Oh, it's the same color. We have the same exact one. Okay. Awesome. Okay. So everybody go to y equals, clear out. Here's all my stuff from inverses in there. I'm just going to clear it all out. And this is really important that you make yourself do this because everyone's calculator is different. So -2, I'm typing in this right here, -2. Okay. Now to get log base 2 on the newer calculators, what you do is you hit the math button. And this is an experiment, so you're seeing if your calculator has it. Hit the math button and then try to find something that says log base. Do you have it? Okay, the bigger question is, does anybody not have it? Because if you don't have it, I need to show you a workaround. Chris, yours has it? Okay, all right, and then just fill in the boxes. So 2x minus 3 plus 4. So you have it? Yep, okay, good. I'll show you. Okay. So, what I'm gonna do is just put the last button and you see whatever is in the parentheses up there. You're gonna press that. And then you're gonna put the other side. Well, and then there's whatever word that you remember. If you leave this in here and just change it as the bottom still, you'll be fine with it. Good. You guys are really paying attention great today. Awesome. Okay, now hit Zoom 6. Zoom 6. Top middle.
Number 6. Go to graph. Go to graph first. Zoom.
No, this is.
That in. Do something. If it do something.
This we need to figure out.
You're doing fine. It's probably already on.
That did not work. Okay, I need to work on yours. I don't know
Okay.
how, or I'm gonna have to YouTube it.
Okay, I'll squeeze there. Okay.
Okay. Oh, I figured it out. Figured it out. Figured it out. Figured it out. I figured it out. Figured it out. Figured it out. Figured it out. How to use Sean's calculator. Every single calculator is different. Okay, so I put the thing in parentheses and then a comma and then the base.
Oh, it's just regular.
Yeah.
X line.
Yes.
That's cost.
Okay, now this one looks pretty decent. I want you guys to graph plain old log base 2 of x now and see how bad it looks. They make it look like a square root graph. You guys are going to have to be smart enough to draw the rest of the line down. If you make it look like a square root graph, I'm going to mark it wrong. Because that means you don't know what you're doing. So you have to know that it goes forever down, even though the calculator is not doing it for you. So big note to self, it does not stop there. That is not an endpoint. It's just your calculator is unable to plug in these x's, unwilling. It's being a toddler. It's not plugging the x's in for you. So you have to know there's an asymptote there. Do you have any questions about graphing the logs? Log graphing? No. Okay. Do you know what the homework is? Okay. Have so much fun with that.
Yeah.